Litter is unavoidable. No matter how clean a place starts, trash returns within hours. This attracts pests, makes public spaces look unclean, and breaks down into pollution that can persist for decades. The problem can't be solved efficiently at the source, so cleanup systems need to keep up, but they don't. Right now, the only solution to litter at scale is human cleanup. But crews only can work for a limited number of hours, they miss items, and it's expensive to cover the same routes over and over. So the results are predictable. Trash accumulates everywhere, even in places spending huge amounts to fight it. For example, San Francisco reports removing 900,000 pounds of litter every week from public areas. And the spending is massive too. San Francisco budgeted nearly $47.8 million for litter removal in 1 year.
So, if litter is nonstop and humans can't solve the problem, we need another solution. That's why we built Litterbot, the first autonomous litter retrieving robot that doesn't just collect waste, but sorts it into recycling, compost, and trash. By deploying fleets of litterbots into environments like campuses, streets, and parks, we can treat litter consistently. This isn't just a concept. The design has already begun as we have been working on AI components for trash detection and spatial awareness, and we're constantly improving a CAD design for real-world conditions such as sidewalk bumps, wet pavement, and rain. Our design focuses on practical reliability, a suspension setup to stay stable on uneven ground, high traction tires to prevent slipping, weather-sealed compartments, and a mechanical arm which can clear obstacles and even get the bot unstuck. The best part is that Litterbot is grounded in a system that already works. Delivery robots have proved that autonomous navigation in pedestrian environments can be real.
At the core is an AI perception system paired with cameras and sensors on the robot. When Litterbot detects a piece of litter, a confidence model classifies the object and determines its category. If confidence meets a 90% threshold, it sorts the item into the correct compartment. If confidence is low, the item goes into a separate review compartment so we don't contaminate recycling or compost streams. And because the system is AI-driven, it improves with real-world use. Litterbot is complemented by Litterbot X, an application that facilitates routing and control, but also provides users with real-time data and customization. The app features a satellite map where users can create routes or pre-suggested ones for the robot to follow. Once a route is chosen, the app allows users to track the robot and see it with a camera and manual control override. The map also displays an estimated trash density and the last cleaning date. As more Litterbots are used, important data is collected in the app, such as trash hotspots and the most common types of trash. This allows users to customize Litterbot to suit their best needs, while also generating crucial data to fighting litter epidemic at its source.
Our team, composed of 3 high school students, has the necessary experience to execute this project, combining engineering, business, and computer science. Furthermore, our Bay Area location provides us with one-of-a-kind opportunities. As the venture capital and tech hub of the world, we have easy access to funding and connections. In terms of customers, studies commonly cite litter costs the US over $11 billion annually in cleanup, meaning we have a wide range of groups we can target. Our first customers are college campuses and city districts where trash is prominent and routes are structured and repeatable. Perfect environments for early fleet deployment. Then we plan to add on large corporate campuses, event venues, and even neighborhoods. Finally, we plan to expand globally into customers who require custom solutions.
Our business model includes a few streams of revenue, such as a one-time cleanup for high-impact events like festivals, monthly rentals to draw in customers, and extended contracts where Litterbot becomes a reliable janitorial layer, running daily routes. But why should people use Litterbot in the first place? Well, compared to current methods, Litterbot has low, predictable operating costs, 24/7 area coverage, built-in analytics, and constant detection, making it an all-around better solution.
The next 2 years will prioritize building and improving the product. A majority of the budget will be allocated to R&D, with smaller shares for recruitment, marketing, and other expenses. This planning will allow us to run a focused beta with local community colleges in 2026 to prove Litterbot works reliably in the real world. In 2027, we will turn to that proof into revenue by selling directly to small towns and universities. By 2030, we plan to expand nationwide, ramping to $210,000 in revenue on $70,000 burn.
Litter isn't going away, but cleanup doesn't have to stay manual, expensive, and reactive. Litterbot shifts us from problem to solution, so public spaces stay clean every day.